The mechanics of our setup are not going to be physically accurate. In other words, a real catapult works a little bit differently than we're going to set it up, but we're going to set it up so that it looks good and it will actually work correctly with the tools. So remember that we're masters of illusion, and we're not trying to simulate reality, we're just trying to create the illusion of reality. So to that end, we're going to use the tools to their best advantage, and that means that our systems that we build are not necessarily going to act truly the way that they would in the real world. So for example, here, the way a real catapult would work is this rope is wound around very, very tightly with the crank, and the arm is held down in a state of tension. And then as soon as the arm is released, this axle will spin very quickly and it will throw the catapult arm up. Okay, well, we can't really do that terribly well in Maya. The best way for us to do this is to simply put a hinge constraint here to hold this end of the arm in place and create a spring constraint which is going to pull the arm upward very quickly. And that'll in turn send this ball shooting off into space. So that's the overview of how we're going to accomplish this. So first thing we'll do is just add our standard rigid body objects. I can in fact just hide the high LOD layer version because that's inert as far as our simulation is concerned. Okay, so passive bodies, what are we going to have here? We're going to have the ground plane and this barrier will be passive rigid bodies. So I got my dynamics menu set, soft rigid bodies, create passive. Let me go into the option box for that and just show it to you. You'll see all the normal attributes that you've seen in the last few lessons. Take note of this as well. There's a switch that says active. So when you add a rigid body node, whether you go through the active menu or the passive menu, it's in fact creating the same node type. And the only difference is the status of this switch. And that active switch can actually be animated. We're not going to do that in this lesson, but I just want you to know that there's only one type of rigid body, and it can be made active or passive as needed. So I'm going to go ahead and create this passively, and then I'll select the other two, the catapult arm and the ball, and we'll create them as active rigid bodies. And once again, if I go to the options, you'll see it's the same dialog because it's the same node type, except this switch is on now. So I'll go ahead and click Create. Now if I press play here, even though I'm getting 24 frames a second and everything seems fine with my time base, I've got my playback speed set to play every frame, max real time. All that's fine, but nothing's happening because there's no gravity. So I'll go ahead and do that. I'll add gravity, dynamics, fields, gravity, rewind and play back. You'll see it's falling very slowly. We saw this before. The issue, of course, is that gravity isn't strong enough. The magnitude of gravity is set to 1/100th of what it needs to be for a model which is built at 1:1 scale. So let me move the gravity node out of the way here. And I've got to increase the magnitude by a factor of 100 to a value of 980. Press enter. Rewind and play. There we go, and it's working fine. Note, by the way, that my catapult arm doesn't even have sides because it didn't need to have sides. It's just a proxy object, and it's just there to calculate the transforms of this high LOD object. So if I turn that visibility back on, you'll see when I press play, the high LOD is following along as well. Good, so we got that going. Next thing we'll do is on that low LOD catapult arm, we'll add a hinge constraint. So back in the soft/rigid bodies menu, you'll see there are constraints. And these are kind of related to the standard animation constraints that you may have seen before, used in rigging, like, for example, point constraint or aim constraint. But these are specific only to active rigid bodies. So I'll go ahead and create a hinge constraint on this one, and that way I can make this spin around that point. Create hinge constraint. It'll be very, very, very small, so you'll need to scale it up. Tell you what, I'll just go over to my channel box and highlight those scale attributes and type in a value of, let's say, 10. Press enter. Maybe a little bit more. Let's try 30. And now it's big enough for me to see. The scale of the constraint icon doesn't affect the simulation. So when I press play, oh, there we go. We've got gravity. And we got a couple of errors, but don't panic on those errors, okay? Because sometimes you'll see some yellow stuff light up down here. Don't panic around that. It's not really something for you to concern yourself with. If it looks good in the viewport, then that's good enough. But the issue that we were seeing here, if I open up the script editor, you'll see it says rigid body interpenetration occurred, and that means that the solver thinks that the two objects have touched or passed through one another. The only reason that's happening, by the way, is because when we create the constraint, it's placed exactly at the location of the rigid body's center of mass. Let me get in really close here and press the 4 key so you can see in wireframe. Let me turn off that high LOD layer as well. And tumble around there. Let me select just the hinge for you. All right, the hinge is actually placed by default exactly on the center of mass of the object, of that rigid body. So let me move the hinge around a little bit, and you'll see this green line connecting the hinge to a little cross. And that cross, or X, is the center of mass for the rigid body object. And when the hinge is created, it's created exactly on top of the center of mass. And we get some inaccuracies because of that. That's why you get that interpenetration error. But if I rewind this now, I play it back and I don't get the error this time. Very good. So let me rewind once again, turn my high LOD back on, and I'll just position that hinge exactly in the center of that axle. I'll need to go into the ortho views to do that, so I'll tap the space bar quickly, go to my front view, zoom in with the hotkeys, just position that right in the center there. Very good. Press the 5 key to show shading, and now I've got pretty much that part of it working. Next thing I need to do is make a spring. A spring constraint will pull the hinge up. But before I do that, you know what? Let me think ahead here for a second, because remember I told you that the center of mass for this low LOD catapult arm, going into wireframe once again, that center of mass is here, and it's not really the optimal place to apply the best leverage to this mechanism. Imagine I tied a rope to the arm right here and pulled it up. I'd have to pull harder in order to get it pulled up. But if I tied it up here at the top, I wouldn't have to pull as hard. So along the same lines, I can maximize the efficiency of this simulation by moving the center of mass over here. And don't worry about the fact that for a real catapult arm, the center of mass wouldn't be way out here. It's just a quirk of the system here that in order to get good results, we actually kind of have to cheat physics. Okay, so how do I move the center of mass? Well, you can't just pick it up and move it, unfortunately. Let me go into my ortho views once again. I'll tap the space bar. What I need to do to move this center of mass around is actually go in the channel box here. So let me scroll down. I've got the low LOD catapult arm selected, and in its rigid body node, scrolling down, you'll see center of mass. Here it is. Center of mass. So it's really the X value that I want to change. So if I, for example, type in a value of 20 and press return, you'll see it moved a little bit here. Well, to move it interactively, the best thing to do is just to highlight the name, center of mass X, and then middle mouse drag in the front view. That way I can drag that over. There is no manipulator for center of mass. The only way to do it is through the channel box. Okay, so anywhere around there is fine.